Hi friends, welcome back to our RxJS tutorial series. In the previous video, we learned the basic building blocks of RxJS. We discussed the four main concepts: observable, observer, subscription, and subject. Then we explored observables in detail. We learned how an observable works, its life cycle, how it communicates with an observer, and several other important concepts. We also created an observable manually using the observable constructor. At the end of the previous video, I mentioned that the constructor is not the only way to create observables. RxJS provides several built-in functions that make observable creation much easier. In this video, we are going to learn those observable creation functions. Let's get started. First, let me show you how we created an observable using the constructor. I will create a variable to store our observable. As a common naming convention, I will add a $sign at the end of the variable name. Since we are going to emit string values, I'll use the type string. Now let's create the observable using the constructor. The constructor accepts a function and that function receives a subscriber object. Inside the function, we can emit values using the next method. Let me emit 3 values. After emitting all the values, I will call complete to notify the observer that no more values will be emitted and the observable has finished its work. Let's preview the application. Nothing is displayed. Do you remember why? Because observables are lazy. Simply creating an observable does not execute it. We need to subscribe to it, and we also need handlers to receive the emitted values. Let me add the subscription. Now, if we preview again, we can see all the values being displayed. Hope that makes sense. Now, instead of writing all this code, RxJS uses a much simpler way. Let's use one of the observable creation functions called off. I will comment out the existing code first. Then I will import off from RxJS. Now I can create the observable like this. All I need to do is pass the values that I want to emit. That's it. If we preview now, we get exactly the same output. Much simpler, right? And off is just one of many creation functions available in RxJS. Some other commonly used creation functions are fromEvent, interval, timer, and many more. At this point, you might have a question. If every observable is just a stream of data, why does RxJS provide so many different ways to create them? That's a great question. The answer is simple. Different types of data sources need different ways of creating observables. Let me explain. In a real application, data can come from many places. Sometimes the data is already available immediately, like the example we just saw. We already have the values, and we simply want to turn them into an observable. In such cases, using the observable constructor is unnecessary. The off function is a much better choice. It is one of the simplest ways to create an observable. You don't need to manually call next, you don't need to manually call complete, and you don't need to write extra boilerplate code. Less code means better readability and easier maintenance. After emitting all the values, off automatically completes the observable. It is also very useful when creating sample data during development or writing unit tests. The off function can emit numbers, strings, objects, arrays, booleans, or even multiple values at once. So it is very flexible when working with static data. For example, imagine your backend API is not ready yet. Instead of waiting for the backend team, you can use off to create mock data and continue developing your frontend application. However, off also has some limitations. It is designed mainly for static and synchronous data. It is not suitable for user events, timers, WebSocket messages, API promises, or continuous streams of data. Now let's look at another common scenario. Suppose we have an API that returns a promise, and we want to convert that promise into an observable. At this point, you may wonder, if a promise already gives me the API data, why should I convert it into an observable? Good question. If we only need a single value and no additional processing, a promise is usually enough. But we often convert promises into observables because we want to use the powerful features provided by RxJS. For example, imagine an API returns 100 users, but you only want the active users. With a promise, You first receive all the data and then perform filtering manually. With an observable, you can use RxJS operators to transform, filter, and process the data before it reaches the subscriber. This makes the code cleaner, more reusable, and easier to maintain. In fact, this is one of the biggest advantages of using observables. Now let's see how we can convert a promise into an observable. For this, we cannot use off. Instead, RxJS provides another creation function called from. Let's see how it works. First, let me comment out the existing code. I already have a backend application running and it provides an endpoint that returns data through a promise. Since this is a promise, we need to use the fetch API to retrieve the data and then use the then method to access the result. Let's preview the application. As you can see, the data is displayed correctly. In Angular applications, however, we usually don't use promises for HTTP requests. Angular's HTTP client already returns observables by default. But for learning purposes, let's see how we can convert a promise into an observable using the from function. I will comment out this code first. Now let's import and use the from function. The from function accepts a promise as an argument. So I will pass the promise here. The result is now an observable. I can store it in my observable variable and subscribe to it just like any other observable. Inside the subscription, I can receive the emitted values. Let's preview the application again. As you can see, we get exactly the same output. One of the biggest advantages of from is that it can convert many different types of data sources into observables. For example, it can convert promises, arrays, strings, sets, maps, iterables, async iterables. Once the data is converted into an observable, we can use all the powerful RxJS operators on it. Another useful feature is that from automatically emits collection items one by one. For example, if we pass an array, it will go through each element and emit them individually. After all values are emitted, the observable automatically completes. However, there are some limitations as well. The first limitation is that we have less control over how values are emitted. RxJS decides the emission behavior. If you need custom timing, complex emission logic, or conditional emissions, creating an observable manually using the constructor may be a better option. Another common source of confusion for beginners is understanding the difference between off and from when working with arrays. Many developers expect them to behave the same way, but they don't. The off function emits the entire array as a single value. The from function emits each element of the array separately one after another. Understanding this difference is very important. Another limitation appears when converting a promise into an observable. Suppose we subscribe to the observable and then unsubscribe from it. The observable stops listening. However, the original promise continues running in the background. Unsubscribing does not cancel the promise execution. Finally, from is mainly designed for existing and finite data sources. This is not intended for things like mouse clicks, keyboard events, timers, WebSocket messages. For those scenarios, RxJS provides other creation functions. One of them is fromEvent. Let's learn about that next. The fromEvent function is one of the most useful RxJS creation functions because it converts browser events into observable streams. But you might be wondering, why do we need to convert browser events into observables? Let me explain. First, I will create a button. Then I will add a click event that calls a function. Inside that function, I will add a simple console log statement. Now if I click the button, we can see the message in the console. Instead of using Angular's click event, let's implement the same behavior using fromEvent. First, I will get a reference to the button using @viewChild. Then I will use the fromEvent function. The fromEvent function requires two arguments. The first argument is the DOM element. The second argument is the event name. The result is an observable. So we can subscribe to it and perform the same console log inside the subscription. Let's preview the application. As you can see, the output is exactly the same. In many ways, this is similar to JavaScript's add event listener. At this point, you may be asking, if Angular already provides a click event, why should I use fromEvent? That's a valid question. For simple button clicks like this, we usually don't need fromEvent. I'm using this example only to help you understand how fromEvent works. The real power of fromEvent becomes clear in more complex scenarios. Let me show you one. This is exactly the same example I used in the first video when explaining why RxJS is useful. Let's create a search input box. I will add a keyUp event and call a function whenever the user types something. Inside that function, I will simply log the value. Now, if we preview the application and start typing, we can see that the log is printed for every single keystroke. For a search feature, this is not ideal. If the user types 5 characters, 5 API calls could be triggered. That creates unnecessary load on both the client and the server. Instead, let's implement the same functionality using fromEvent. If we preview now, we get the same behavior. But there is one important difference. This is now an observable. And because it is an observable, we can use RxJS operators to improve the behavior. For example, let's add the debounce time operator. Now watch what happens. When I type continuously, the event is not triggered immediately. The observable waits for the specified time period before emitting the value. As a result, the console log appears only once after I stop typing. This means only one API call is made instead of multiple API calls. And this is one of the biggest reasons developers use RxJS and fromEvent in real-world applications. Okay, let me show you one more example. Let's go back to our button example. Sometime when users submit a form, they accidentally click the submit button multiple times. As a result, the form may be submitted more than once, which can lead to duplicate records, duplicate payments, or other unwanted behavior. We can solve this easily using our fromEvent approach. Since the button click is now an observable, we can use RxJS operators such as throttle time. Let me add throttle time here. Now let's preview the application. If I click the button twice within 1 second, notice that only the first click is processed. The second click is ignored. This helps prevent accidental multiple submissions. I hope this example gives you a better understanding of why converting DOM events into observables can be useful and how fromEvent helps us build more powerful event handling logic. However, even though fromEvent is powerful, it is not always the best choice. For simple click events, Angular's built-in event binding is usually easier and more readable. Also remember that fromEvent creates a subscription. That means we are responsible for unsubscribing when it is no longer needed. If you forget to unsubscribe, it can lead to memory leaks. In large applications, there may be hundreds of DOM elements and event listeners. If subscriptions are not managed properly, they can affect application performance. So always use fromEvent when you need the power of RxJS operators, not for every simple event. So far, we have created observables from existing data sources. But what if you want to generate values automatically over time? For example, imagine building a countdown timer. We may want to update the value every second. RxJS provides a very useful function for this called interval. Let me show you how it works. First, I will create a variable called count and initialize it with a value. Then I will display this value in the template. Now let's use the interval function. The interval function accepts a time period in milliseconds. I will pass 1000, which means 1 second. The interval function returns an observable. So let's subscribe to it. Inside the subscription, I will decrease the count value. Now let's preview the application. As you can see, the countdown decreases every second. But notice something. Even after reaching 0, it continues going into negative numbers. Why is that happening? Because interval creates an infinite observable. It keeps emitting values forever until we stop it. To stop it, we need to unsubscribe. Let's store the subscription in a variable. Then we can add some logic to unsubscribe when the count reaches 0. Now if we preview again, the countdown stops exactly at 0. Much better. RxJS also provides another time-based creation function called timer. Many beginners get confused between timer and interval. A simple way to remember them is this. Timer is similar to JavaScript setTimeout and interval is similar to JavaScript setInterval. Let me show you a quick example using timer. Here I want to print a message after a delay of 5 seconds. I will use timer and provide a delay of 5000 milliseconds. Now let's preview the application. After 5 seconds, we can see the message printed. That's how timer works. I hope the difference between interval and timer is clear now. Alright, that's all for today's video. In this video, we explored some of the most commonly used ways to create observables in RxJS. We started with the Observable Constructor and learned how to create observables manually when we need complete control over their behavior. Then we looked at off, which is useful for creating observables from static values. After that, we learned about from and saw how it can convert existing data sources such as arrays, promises, strings, sets, and other iterable objects into observables. We also compared off and from, which is one of the most common areas of confusion for beginners. Next, we explored fromEvent and learned how to convert browser events into observable streams, allowing us to apply powerful RxJS operators such as debounce time and throttle time. Finally, we learned about interval and timer and saw how they help us create time-based observables for scenarios such as countdown timers, delayed actions, polling, and auto-refresh functionality. At this point, you should have a good understanding of the different ways we can create observables and when to use each one. But creating an observable is only the beginning. In real-world applications, we rarely use the data exactly as it is emitted. Most of the time, we need to transform data, filter it, limit it, combine multiple streams, or perform additional actions before using it. And that is where RxJS operators become extremely important. In the next video, we'll start exploring some of the most commonly used RxJS operators and learn how they help us process and manipulate observable streams efficiently. Thank you for watching. If you found this video helpful, please hit the like button and share it with your friends. And if you are new to this channel, don't forget to subscribe and support the channel. See you in the next video. Bye.